Now, so from here, you see, so the quantity, specific latent heat, which is the quantity of heat that's absorbed or released during the change of phase of 1 kg of substance without the change of temperature. Okay. Now, so the specific latent heat normally is I is equals to heat over mass Q over M. Okay, or Q equals to ml. Okay, so the SI unit for I, which is the specific latent heat, is joule per kg. Okay, so the two types of specific latent heat, like I said, fusion and vaporizations. Fusion is from solid to liquid or from liquid to solid. Vaporization is from liquid to gas or gas to liquid. Okay, can I jot this out? Yeah. So far, if you guys don't know understand what you have to let me know. So maybe I can change the little bit way on discuss something like that. Okay. Sudasan, your mom said, asked me to inform you after tuition back to grandma house. Okay. Done, huh? Okay, so now let's see the definition of we call the latent heat of fusion. Okay, so what is a fusion? Fusion is a process where the solid change to liquid when the heat is absorbed. So the specific latent heat for fusion is the quantity of heat required to change 1 kg substance at a constant temperature. And the process involved is melting and freezing, where melting, the heat is absorbed, freezing, the heat is released. And for vaporizations, it's a process where the liquid change to gas when the heat is absorbed. So it's the quantity of heat required to change 1 kg of substance at a constant temperature. Okay, actually change 1 kg of substance from liquid to gas. Okay, so the process involves boiling where the heat is absorbed and condensation where the heat is released. Okay, can I? Right, got this down. Done, huh? Yes, sir. All right, so let's see the next one. Huh? So let's see, this one is called the heating curves. Okay, so you see for heating curves, normally we let's say if I in from A to B is a solid, while B to C is from solid to liquid. Okay, CD is liquid, D to E is from liquid to gas, and from E to F will be G. So normally in here, this is where the latent heat comes in. Okay, so now, okay, I think you draw this one first. You draw this one first. Okay, then we discuss how the process for each of them. Okay, you draw this one first. Done, huh?
Yes, yes.
All right, so let's continue. Now, from the process, you see at A, B, C, D, and E, F, which is the solid state, liquid state, and gas state. So what happened is the heat is absorbed, so the temperature increases, and the kinetic energy of the molecule increases. Now, in BC is this one. The latent heat is absorbed to weaken the bond between the molecule. Okay, this is the latent heat of fusion, and the molecule are released, okay, from their fixed position and move throughout the liquid because it absorbs energy. So the energy content is higher. When energy content is higher, we say that atom or that molecule is excited. Okay, that's why they will break off from the fixed position and move around. Okay, and the kinetic of the molecule and temperature will remain unchanged. Why? Because the heat energy has been used to weaken or break the bond. Okay, now in DE is where from liquid to gas. Now, the latent heat is absorbed to break the bond, which is the latent heat of vaporizations, and molecules will be separated far away. Just now it's just from fixed to not fixed. Now they will go even far further away because more energy is absorbed. So more excited, the excitation level is higher. So the kinetic energy of molecule and temperature remain unchanged because same reason. The heat energy has been used to weaken or break the bond. That's why it doesn't show the increase of temperature during this phase. Can you understand? Can you don't later on exam forget This is important one Okay, jot this down. Now, sorry, done. All right, so let's see now. Now this is the cooling curve. Just now is the heating curve, this one is cooling curve. Okay, now what I want you to do is, now you have the cooling curve, right? And you have what, just now I've shown you what's the look like. So now you need to do according to just now what you do by yourself before we discuss. This one's the balik only, right? So let's see what's your what you call, how good your understanding is. Yeah. All right. Sure. Done. Huh?
Yeah.
Okay. So let's see whether you are correct or not. Huh? Now, for NO, PQ, and RS, the heat is released and the temperature decrease, and your kinetic energy contained is decreased. Okay. Now, OP from gas to liquid. So the latent heat is released to form molecular bond, and the molecules will move with each other, and the kinetic energy of the molecule and temperature remain unchanged because the heat released to form the bond, okay, is to form the bond. And then why the temperature remain unchanged? Because it has been compensated by the heat release. Okay, now next. For QR is where from what I call from liquid to solid. So the latent heat is released to strengthen the bond between the molecule. Now, this time it's formed the bond, now it's strengthened the bond. Huh? And why strengthen the bond? Because actually they already have bonds. Liquid and solid, the difference between them is chemically, the chemical structure is already very near to each other. It's just that now we need to go even nearer. Okay, so the molecule will vibrate around the fixed position because it's solid mass. So this is what happened in solid. And the kinetic energy and temperature remain unchanged because the heat release has been used to strengthen the bond.
So,
Mm.
temperature increase one, right? The molecules separate far from each other, right?
Yeah.
So I can put the molecule near to each other.
Can.
Yeah.
All right. So you can jot down if anything that you miss. Correct? Okay, good. So now let us continue with the experiment. So you see the experiment, there are two. One is to determine the specific latent heat of fusion of ice. So this is the setup involved. And the other one is to determine the specific latent heat of vaporizations. So you see here, there's for set A, he's using the immersion heater, put it inside the ice. Okay. Okay, one with no power, one go to power supply. Why one with no power? Because we want this one is a control subject. Okay, then this one, then they collect the water that put on that they collect the water in the beaker and then weight it by weight it means that take the measurement. Okay, by using the electronic balance. Okay, same goes here. This is to check how much water has been vaporized. Okay, can you understand? Okay, so jot these two and then draw these two. Because later on we will discuss about the way, and then I will how to say, I want to discuss a bit on this, how they analyze the data, all this, because might comes up in your, we call the paper 3. Paper 3 got 2 questions, but one is you need to do the experiment, right? The other one is without the experiment, but you need to discuss all this. So we need to talk about that.
Really talking about other people. Nggak bisa slow punk. Finish.
All finish, huh? All right, so let's continue. Okay, now let's see. Like I said, this one, first you use the immersion heater, one is by heating, one is connected with power. That means the heater is on, one without. Okay, then now, so now the mass of each of the two empty beaker is determined by using the electronic balance, and each of them with the filter funnels is filled with ice cube. So set A is a control experiment which is not connected to power supply. Why? This one is to determine the mass of ice melted by the surrounding heat. Then we switch on the one in set B. So when the water start to drip from the filter funnel at a steady rate, the stopwatch start and the empty beakers A, B are placed on the beneath the filter funnel. So it means that we need to switch on a bit time first until the water now become dripping is now constant. Then we put the beaker inside. So after a bunch of T seconds, the heater is switched off, B is switched off. Then the mass for both A, B are determined by using the electronic balance. The power of heater is recorded. Now, for the other one, much more easy. So is where first, the beaker is placed on the electronic balance, and then we put the immersion heater fully immersed in water. Okay, and we hold the position by using the record stand. Then we switch on and heat the water until the boiling point. So when the water starts to boil at steady rate, then we start the stopwatch, and the first reading, the initial reading of the mass on the electronic balance, we recorded. Because we want to know how much the difference are. So we need to record the initial one first. Then we allow them to boil for like several seconds. How many seconds? Normally 30 lah. Okay, 20, 10 maybe it's too small. Maybe 20 or 30. Okay. So at the end, after the T second, then we record again the reading at the electronic balance. And then the power is recorded. So you see, normally this is how the setup. You need to mention the set A, set B, the power of heater, and time of heating. For this one is initial, final, time, and the power of heating. So how the power of heating was calculated? This two is using the same formula you will find out. Okay. Sorry, a bit different, just a bit different. So the specific latent heat of fusion is by using E equals to PT, Q equals to ML for fusion. So there's an assumption. First, the assumption is assume that no heat loss to surrounding. They might ask, what's the assumption made? No heat loss to surrounding. So PT equals to ML. So rearrange I is equal to PT over M2 minus M1. Now, for this one, okay, we assume that heat loss to surrounding is negligible. One, but how we do it? By applying tissue at the side of the beaker. Second, all heat supplied by the heater is absorbed by water, because somehow the heater is also like radiation, the radiation type, the heating. So some of it might loss to surrounding, but we consider 100%. No heat loss, efficiency 100%. So by using the formula, Q equals to E, also the same thing. So we rearrange MLV equals to PT, LV equals to M1 minus M2. Why M1 minus M2? Because after boiling, the final one normally is smaller, right? So we use the big one minus the small one. Can you understand? Can I? So just now this. You sure? Understand?
Yeah.
Don't understand, you don't like. Yes, but don't know. Now you guys now you becoming the lesser and lesser. You guys try help me to get more students come in. Maybe you Kitahana you go and tipu some guy, Sudasan go and tipu some girl come in. Seems like she's talking some candidate, is it? You have a candidate, so
No, teacher. She's talking about something.
And also remember if you introduce someone and then they did come in, so every month you will get a discount of 5 ringgit per head per head. So no matter, doesn't necessarily must be Form 4. You can, as long as anyone, I mean from another, I consider the discount. If like Sudasan, yours is 50 per month. If you can find 10%, no problem, you're free. But try to get those people who are also taking in English one, because somehow Malay one, I'm afraid they might have a problem, because we need to explain in Malay and English, and mostly, you see, dual language is not easy to be explained. Something like that.
So faster dulu lah.
Done, All right, so now let's see the application. First, we try to see the one in refrigerator. So I explain briefly first before we go. So now, first, from the compressor, so the compressor will compress the cooling agent, which is a kind of gas. Okay, this is to increase the pressure, and also to increase the the temperature, to increase the temperature of the cooling agent, and then it will be moved towards the expansion valve here. But first, it will go to the condenser, where in condenser, okay, which is the outside, where because the temperature is higher, correct? Outside is cooler, so the heat will move out, will be released through the condenser. Okay, then now the cold air will enter the expansion valve. Okay, and then from expansion valve, it moves to the evaporator, where in evaporator, the cooling agent now will absorb the heat from the evaporator, which is your refrigerator, the place where you put your cheese lah, maybe you put your Coca-Cola lah, something like that. Okay, the chilling zone lah. So you absorb the heat. So that's why you can maintain chilling lah, because the heat has been absorbed out. And then the heat, after the heat has been absorbed, the cooling agent will flow back to the compressor, and then will pump out again to release the heat, and then back absorb heat, release heat, like that. Okay, can you understand?
Yes.
Can I?
Yes.
It's like what, you know, it's like you know the it's like the function of the fan that can spray water. Why they spray the water? This is to cool down the area, correct? So cool down where the water vapor will absorb the heat and then moving out. So that area will cool down. Same goes here. This is what happened here, where the cooling agent will flow through the evaporator, where all the heat inside will be absorbed. It's not gonna release the what you call, it's not gonna like release the cooling agent into the evaporator. No, if like that, your fruit all cannot eat. Eat you die. Okay, because it's a toxic. Okay, so something like that. So like now, the compressor will compress the cooling agent to increase the pressure and temperature. Then, when reach the condenser, the cooling agent will release the latent heat during the condensation process. Okay, then it will move from gas to liquid in this time. Then the liquid will will flow through the expansion valve and enter the evaporator, where inside the evaporator, the cooling agent will absorb the latent heat from the air inside the refrigerator. And now when it absorb heat, so it will form again from liquid to here, from liquid to gas. See, from liquid to gas, and then back to the compressor. Can you understand? Can I?
Yes.
Okay. So just now, you can draw this but no need to draw this hard like. Maybe you can just like compressor, then blah. This one, the evaporator, you doesn't need to draw like this. The evaporator, you just big box evaporator, that no need to draw like this.
Pasti jadi besok. Ini masih buat ini tahu. Ya, itu saya yang ada. Oh, nah, it's fine. Ini bodoh. Apa? Yeah. Said I so far didn't do that.
Now let's see the evaporation of sweat. So where your sweat will evaporate, so the sweat will absorb the latent heat of vaporization from your skin surface, and then the skin surface will lose heat, which cause the temperature of skin surface drop down. Okay, pretty easy lah. Okay, now the next one. The steam, when we steam food by using a steamer, water has a high specific latent heat of vaporizations, and steam will condenses on the surface of food. So the high latent heat of vaporization will release and absorbed by the food, and the food will be cooked thoroughly and perfectly. Okay, because it's heated, so it will the steam later on will condensate on the surface of food. So there is a heat there, so the food will absorb the heat, and the temperature of the food now will increase. So this is how we cook. Okay, can I? Okay, got this out.
Just lupa gitu.
Don't worry. Speed doesn't mean anything.
Just speed. Just work everything.
Normally lah. Speed doesn't means anything. Why? You see, when you go too fast, you must understand. Yeah, like I said, like she said, understanding is the most important one.
She's talking and
But you know, I can understand.
she lying. Just doesn't matter.
Done?
Yes.
Done, All
yes.
right. So let's. Okay. Yeah.
Nothing like the actually. I really want to understand that I could be able to
And can see.
Cancer.
Sure.
Yeah.
Is it too small?
Little bit too small.
Let me.
One, two, three, four.
Yeah, I try to adjust first. Like this.
Yes.
Okay.
Also. What's this? Before, here. What's this? One.
OK，我等下这空完我看啊。
Yeah. Just. Eight.
Yes, don't worry. I just check whether you can do it. I think I make this your, yeah, because we just have another 10 more minutes and I don't think you can finish it on time. So I think I will cut this as a, and then I send it into the group. Well, don't be too lazy. You guys need more exercise nowadays. It's, just try your best to finish it. If you are not able, I doesn't really care, but don't purposely not able to finish it. What I'm trying to say is you can try to finish it, but too much homework, maybe you do until question 4, okay, can acceptable. Uh, no, I'm preparing for my next class student. Yes, every day 4 class, every day, and even Saturday, and 1 class for Sunday. But sometimes I need to help my professor to took up some classes as well because he's very lazy nowadays. Don't know why.
Yeah.
Okay, I think I will stop here for today. So, any questions before we dismiss? All right. Okay, I think.